morning and welcome back to Relief Tutorials. In the last lecture, we were discussing about refractive index of refracting medium with respect to incident medium, and we have seen the general formula for that: speed of light in medium 1 upon speed of light in medium 2. Symbol for refractive index is eta. Previously, we have seen laws of refraction, in which the second law was Snell's law, and according to it, sine of angle of incidence, ratio of sine of angle of incidence to sine of angle of refraction is always remains constant, and the value of that constant is refractive index of medium 2 with respect to medium 1. This was the result number 1, and this was the first formula for a refractive index of medium 2 with respect to medium 1. So this is our result number 1. Sin I by sin R is equals to eta to 1. Okay. Now according to definition, relative refractive index means if the incident medium is other than air or vacuum. Consider, let's have some more examples on that. Consider here is water, the first medium, and glass be the second medium. This is incident ray going from water to glass, means from rare medium to dense medium. Okay, so when the light ray goes from rare medium to dense medium, it moves towards normal. This is angle of incidence and here is angle of refraction. Now according to this formula, what should be the formula for refractive index? Here the refracting medium is glass, so refractive index will be of glass. So what we can write? Refractive index of glass, G for glass, refractive index of glass with respect to water. So with respect to water is equals to speed of light in medium 1 means speed of light in water. So dW means speed of light in water upon speed of light in glass. Another formula that at the same time we can write according to this law, sine of angle of incidence. Let us say this is theta water, means angle formed in water medium upon angle formed in glass medium. These are nothing but the angle of incidence and angle of refraction only. So at the same time, another formula we can write here, sine theta W upon sine theta glass. So this is refractive index of second medium with respect to first medium is equal to speed of light in first medium upon speed of light in second medium is equals to sine of angle of incidence upon sine of angle of refraction. One more example. Consider here is glass. Let us say here is diamond, the most dense medium, and here is water. Ray goes from diamond, here is normal. Comparison of the density between these two, diamond is more denser as compared to water. So here the ray goes from dense medium to rare medium. So when the ray goes from dense medium to rare medium, it moves away from normal, so like this. So here is the angle of incidence, let us say theta diamond, and this is angle of refraction theta water. Now what formula you can write for refractive index? Again, refractive index will be of water here. So refractive index of water. See, refractive index is always of refracting medium, means second medium. So refractive index of water with respect to diamond is equals to speed of light in first medium means speed of light in diamond upon speed of light in second medium means water is equals to, again, sine of angle of incidence means sine theta D upon sine theta water. One more. Consider this is medium number 1 and medium number 2. No specific medium we are writing here. Consider this is incident ray, here is normal, and this is refracted ray. So this angle is theta 1 and this angle is theta 2. So formula theta 2, refractive index of 2 with respect to 1 is equals to speed of light in medium number 1 means V1 by V2, and that is equals to sin theta 1 by sin theta. Now if the incident medium is air, if incident medium is air, then that refractive index is called as absolute refractive index. Let us say this is air and here is glass. So ray goes from air to glass like this. Okay. So what we can write here? Eta of G with respect to A. Refractive index of glass with respect to air. But remember, when the incident medium is air or vacuum, no need to write this incident medium here in the formula. So it's simply called as what? Refractive index of glass. If there is no comparison with the incident medium, that incident medium would be air or vacuum always. So incident medium, refractive index of glass with respect to air. No need to specify here what should be the formula. Then speed of light in medium number 1. So speed of light in medium 1 means speed of light in air or vacuum. And speed of light in air or vacuum is the fastest one, 3 into 10 raised to 8 meter per second, and that is symbolized as C upon speed of light in glass. So C by speed of light in glass. If I say first medium is air and second medium is diamond, then what would be the formula? Refractive index of diamond with respect to air, no need to specify, and that is equals to speed of light in air means C upon speed of light in diamond, this way. So if I ask you the formula of eta 21, so eta 21 would be V1 by V2 according to this formula. If I ask you formula eta 43 means refractive index of medium number 4 with respect to 3, so the formula would be V3 by V4. Okay. If I ask you the formula eta 2, so this symbol itself represents what? That this is absolute refractive index, and when the refractive index is absolute, incident medium is fixed, and if the incident medium is fixed, numerator in this formula would be always C, because speed of light in air or vacuum, that is always C. So in the formula of absolute refractive index, numerator is always C. C means 3 into 10 raised to 8 meter per second. So C upon speed of light in medium 2. If I ask you eta 1, then what? C by V1. If I ask you eta G for glass, so refractive index of glass with respect to air. Air means that would be absolute refractive index of glass. Absolute refractive index of glass is C by Vg. Absolute refractive index of water means C by Vw. What was the first result? Eta 21 is equals to sin theta 1 upon sin theta 2. Sometimes it is written sin I by sin R, whatever you write. Nothing but this is nothing but the sign of angle of incidence and sign of angle of reflection. Now, what is the second result? That eta 21 is equals to V1 by V2. Now, let us derive the third result, which is very important here. That is nothing but the relation between relative refractive index and absolute refractive index. Okay, so what is the value of eta 1? Eta 1 is C by V1 and eta 2 is C by V2. Here it is. Now divide eta 2 by eta 1. Eta 2 by eta 1. So what would be the step? Eta 2 by eta 1 is equals to, eta 2 means C by V2 upon C by V1. So C into V1 by C into V2. C cancelled here. So V1 by V2. So finally it is eta 2 by eta 1 is equals to V1 by V2. But if you see, what do you mean by this V1 by V2? V1 by V2 is nothing but eta 2 1. So we can replace V1 by V2 by eta 2 1. So the next step would be eta 2 by eta 1 is equals to, in place of V1 by V2 we can add eta 2 1. Result number 3 and the formula number 3 for eta 2 1. So eta 2 1 is equals to ratio of sine of angle of incidence to sine of angle of refraction 1. Second formula eta 2 1 is V1 by V2, and the third formula eta 2 1 means eta 2 by eta 1. Three different formulas for eta 2 1. Eta 2 1 is sine theta 1 upon sine theta 2, V1 by V2, and eta 2 by eta 1. So this is all about refractive index and the types of them, and three different formulas for eta 2 1. Now, one more small topic. Refraction through glass slab. Refraction through glass slab. Consider this is one of the glass slab. Rectangular glass slab. One of the oblique light ray comes from this angle. This is incident ray. This is the first refracting interface, because here the medium is air and here it is glass. This is the glass medium. So this ray going from air to glass means rare medium to dense medium. So obviously it will move towards normal. Okay, so here is the normal, and this is its original path. So consider, if there is no glass slab, means in absence of glass slab, the ray would be traveling like this. But here the glass slab is present. So this is the original incident path. This path is called as original incident path in absence of glass slab. This is normal. This is the point of incidence here. This angle is angle of incidence here in this case. Let us say it's theta 1. Now the ray will be deviated towards normal like this. So this angle is angle of refraction, theta 2. Now this ray again changing the medium, because now this ray is traveling in glass and now it comes again to air. So these walls, let us give some name PQ. This PQ surface is first interface, and let us say this RS is second interface. So first refraction occurs at interface PQ, and second refraction is going to occur at interface RS. At PQ, the ray is going from air to glass. The ray is going from air to glass, and now the ray is coming from glass to air. Here again the normal can be drawn. This is normal, and as we know, when the light ray going from dense medium to rare medium, it moves away from normal. So it moves like this. So this is the final ray which is coming out. So in this case, the first ray which is coming from air is called as incident ray. This second ray which is traveling inside the glass is called as refracted ray, and the ray which is coming out is called as emergent ray. Now, as we have seen, in absence of glass slab, this would be the path of incident ray. If there is no glass slab coming in the path, let us say this is point A, here is point B, point C, and point D. So path A, B, C, D. Path A, B, C, D is the original incident path in absence of glass slab. But when we have placed the glass slab in the path, the ray is bending first time at interface PQ like this. Let us say this is BE. So BE is refracted ray, and let us say EF is the final emergent ray. If you observe it, or let us say the conditions first. This PQ, the first interface, and RS, the second interface, means if these two sides of rectangular glass slab are parallel, if PQ and RS are parallel, then the final emergent ray, listen to me carefully, if PQ and RS are the two interfaces, if they are parallel, then the final emergent ray, can you see the figure, that final emergent ray going in the same direction as the original incident ray was going on? See, original incident ray is going like this, and the final emergent ray going in the same direction. Both are parallel, both are going in the same direction, but the path is slightly shifted. If there was no glass slab, the light ray was A, B, C, D. Okay, but if the glass slab is present, the ray is still going in the same direction, but the path is shifted. Okay, so if you see the final emergent ray and the original incident ray, both are parallel. If you measure the perpendicular distance between these two parallel sides, you can find out by how much the ray is shifted. Look at this. This is the perpendicular distance between these two. Here also you can measure, wherever you can measure the distance between two parallel sides remains always same. So I think this is the distance. I think from this point they are parallel. Before this they were not, but now they are parallel. So this is the lateral shift. This is called as what? Lateral shift. This is the distance by which the incident ray is shifted. That is why it is called as what? Lateral shift, horizontal shift. So CE, or this distance is called as lateral shift, and this is the shift of incident ray, and that is because of the glass slab. If you remove the glass slab, the ray will be traveling in ABCD direction. Again, if you place the glass slab here at the same point, again the ray will be refracted and then again emerge out like this. So this angle, this is the path deviated. So this is the distance by which the ray is shifted. That is why it is called as lateral shift. Now this distance, see, this distance means lateral shift distance depends on many factors. Consider this is angle of incidence. Look at this. Theta 1 is angle of incidence. Theta 2 is angle of refraction for the interface PQ. This is theta 3, and this angle is angle of incidence for interface SR, and this is normal. So this angle is theta 4, and this angle theta 4 is angle of refraction for interface SR. But as a whole, if you consider this is a single case, theta 1 is called as angle of incidence, theta 2 is angle of diffraction, theta 3 and theta 2 both are having the same value because they are the alternate angles formed by the two parallel rays, so not considered here. Theta 4 is called as angle of emergence. Theta 4 is called as angle of emergence. And remember, this angle theta 1, this angle theta 1 is always equals to theta 4 because these two sides are parallel. Okay, so what do you mean by lateral shift? Lateral shift means what? When the glass slab is placed in the path of incident ray, the path of incident ray is slightly shifted, and this distance is called as lateral shift. So here distance CE is called as lateral shift. This distance CE distance is called as lateral shift. Now this lateral shift means by how much the ray will be shifted, it depends on many factors. So the topic is factors affecting lateral shift. The first factor, consider, see this is ray AB, this is angle of incidence. Imagine the ray is more oblique like this. Same glass slab, same air glass and air medium, but the ray is having the larger angle of incidence than the previous. Then what would happen? Consider this was the first case. This original incident path and like this. And now if the angle of incidence here increases, if the ray goes like so, this is the original path, the ray will be reflected like this and comes like this. So this will be the new shift. This was the first lateral shift, and this will be the second lateral shift if the angle of incidence increases. So as the angle of incidence here increases, lateral shift for the same glass slab increases. So if you want to increase the lateral shift, you have to increase the angle of incidence. So the first factor on which the lateral shift depends is what? Angle of incidence. So can I write like this? That lateral shift is directly proportional to angle of incidence. Directly proportional means as the angle of incidence increases, lateral shift increases. As the angle of incidence decreases, lateral shift also decreases. Second factor on which it depends is the material of glass. Consider this is one of the glass slab. This is one of the incident ray. Okay, and this is the shifted ray. So this is lateral shift here. Okay. Now don't change the angle of incidence. We are keeping this factor constant, but let us replace the glass slab. Right now, the refractive index of this glass means the material, the density of this glass. Let us say the refractive index of this glass slab is 1.5. Now, if refractive index of this glass slab increases, if I place such type of glass slab having the more denser medium, thick glass, that means we can say, then what? If the glass medium is more thicker, then obviously the refraction here will be slightly more. If the optical density of this glass slab increases, refractive index increases, means its capacity to deviate the light ray increases. So this would be the refracted ray and this would be the emergent ray. So then here you can see the lateral shift increases for the same angle of incidence, for the same air glass and air combination. If the refractive index of glass increases, means if the density of refracting medium increases, lateral shift increases. So second factor on which lateral shift depends is, you can write, lateral shift is directly proportional to refractive index of glass slab. Okay. Third factor. Consider we are not changing the glass slab, but we are changing the dimension. We are not changing the refractive index of glass. Consider this is one of the glass slab, and this is one of the lateral shift. This is the shift. Now we are not changing the material of glass. We are changing the dimension of glass. Let us place this type of glass slab now, having the distance between these two parallel sides is slightly more. Second glass slab having more distance between these two parallel interfaces, then what would happen? We are not changing the angle of incidence. So this angle of incidence we are keeping same like this. Material. See, the size changes but not the material. If the material is same, means its refractive index is also same. So we are not changing the refractive index. So the light ray travels like this. But because the distance between these two interfaces is slightly more, the ray has to travel more distance in the glass itself, and then it comes out like this. So the lateral shift is like this, slightly increases. So as the distance between these two parallel interfaces increases, light ray has to travel more distance in the glass slab, so the lateral shift increases. If you take this type of glass slab, this one, now, then the light ray has to travel a very short distance in the glass slab and comes out like this. So this is the lateral shift. So lateral shift is also directly proportional to parallel, the distance between two parallel interfaces of glass slab. As the distance between these two parallel interfaces increases, shift increases. If distance decreases, shift also decreases. See, this is the end of this topic also. Two small things are there. Consider, if I write like this, refractive index of water. I am not mentioning any medium here, means what? If I am not mentioning any second medium here means the medium is air. So eta W means what? It is C by VW. If I say eta glass, means it will be what? C by V. Now if you just assume the values, value of C is always what? C into 10 raised to 8 meter per second. And denominator, speed of light in water. And speed of light in water is always less than this value. So in such type of cases, in the absolute refractive index, numerator is always bigger than the denominator. So if numerator is always bigger than denominator, I think the ratio will be always bigger than 1. So remember, absolute refractive index of any medium is always bigger than 1. One thing. Second thing, if I say incident medium is air, and refracting medium is also air. Now incident medium is air, refracting medium is air, then what? Then for formula for absolute refractive index will be what? C by C. If I say here is glass, then will be what? Vg. But if I say here is air again, absolute refractive index of air. I am asking absolute refractive index of air. So absolute refractive index of air means C by C. And C by C, I think the value is 1. So absolute refractive index of air is always 1, and absolute refractive index of any medium other than air is always more than 1. Now if I say absolute refractive index of water is 1.3 and absolute refractive index of glass is 1.5, absolute refractive index of diamond is 2.42, then what can we conclude from these values? Look at the values. Refractive index of diamond is 2.42. It indicates us that this is the most optically denser medium. This is the most optically denser medium, so it can deviate the ray most. When the ray goes from air to diamond, the ray will be deviated the most. If I say what is the value of eta air? Eta air is always what? 1. So look at these values. You remember these 4 values. Actually, eta of water is 1.33. Sometimes we use 1.33, sometimes it is 1.3. Okay, so that's all for today. Be practicing refraction, definition of refraction we have seen, Snell's law, laws of refraction, refractive indices, relative refractive index, absolute refractive index, their formulas, lateral shift, dependence, and all these values.